This new EV is the latest Tesla killer. Insert pretty much any company there and you have yourself a great headline. Yet, even with these cars coming to market, Tesla remains the EV leader in the US and worldwide. Why is that? Is it actually possible that Tesla makes $140,000 more per EV than Ford? Today we're breaking down everything that has led to this, and how Tesla manages to keep such a lead in the EV space. So let's get into it. When it comes to selling vehicles, and especially electric vehicles, customers obviously want prices to come down. We are starting to see price drops on electric cars, and that's very exciting. For example, you can purchase a long-range, rear-wheel drive Model 3 with a range of 363 miles for $42,490 today. That car qualifies for a $7,500 tax credit applied at the point of purchase, so if you qualify, you're looking at a car in the upper 30,000s with plenty of driving range. Looking back over the last few years though, EVs have been more expensive than gas-equivalent cars, and ultimately that's due to the larger battery pack required to deliver a functional driving range. When Tesla unveiled the Model 3, and then finally shipped it, it was a very big deal. They claimed that that car would start at $35,000, and at certain points in time it has started at that price. Then came the Model Y, which took all of the technology from the Model 3 and put it into a crossover SUV shape. That shape is extremely popular and has led to this car being the best-selling car of any type in the world. Tesla sells more Model Ys than any other company sells a single vehicle model, gas or electric. Obviously, we still need a more affordable EV to come to market, but progress is rolling in that direction swiftly. This is thanks to a lot of the technology and design of the car, but also the way that Tesla has been able to efficiently scale up production. Recently, I made a video breaking down how Tesla is able to build a new car every 13 seconds. They have achieved this by scaling up multiple different factories and always taking things from a first principles approach. They question every step in the design and production process in order to make sure that every single process is efficient. In fact, they have a quote algorithm that they live by with the steps 1. Question every requirement, 2. Delete any part or process you can, 3. Simplify and optimize, 4. Accelerate cycle time, and 5. Automate. They built up a battery factory with Panasonic, which became the highest volume battery plant in the world. They expanded their Fremont factory, opened their incredible effective Chinese factory, opened their Berlin factory, and opened their Texas factory. Today they make the Model S and X in Fremont, the Model 3 in Fremont in China, the Model Y in all 4 factories, and the Cybertruck in Texas. When you look at their full production capacity globally, they are capable of producing 2,350,000 vehicles per year, which essentially means that they can produce a new car every 13.41 seconds. It's a remarkable feat considering they only make battery electric cars, but it's even more remarkable because they profit on every car that they sell. Over the past year, Tesla made about $78.5 billion in auto revenue alone. Over that time, they have been quite profitable as well. For example, even as we are seeing Tesla's profits drop in recent quarters, likely due to price drops, they still reported a 6.3% operating margin for Q2 of 2024. This means they are still plenty profitable on the cars that they sell, and ultimately, that's the most important thing. For a company to continue growing, continue selling more cars, scale production, and ultimately have enough capital to fund research and development for a future cheaper electric car, they need profits. It's always a balance because on one side, customers want lower prices and are frustrated to hear how much a company made on the car that they just bought. On the other side, this is how business works. If they don't profit on their vehicles, they simply will go out of business before a cheaper vehicle can arrive. In any case, this is the metric by which Tesla has everybody beat by a long shot. When it comes to vehicle production, Tesla is scaled up more than any other automaker. For Q2 of 2024, Tesla delivered a total of 443,956 electric vehicles and produced around 410,000. That's impressive and includes their worldwide sales. But it's even crazier when you look at which automaker was in second place in the US. Ford sold the second most EVs in the US for Q2, selling 23,957 total. This marked impressive growth for Ford, with their EV growth surging 61% year over year. But at the end of the day, even with that massive surge, Tesla sold 18 times more electric vehicles than Ford. So we are seeing Tesla's market share drop, but it has dropped to 49.7% in the US, still completely beating everyone else. This chart illustrates it pretty well. We can see Tesla's market share falling, but considering that this is one single company compared to the entire rest of the industry, it was only a matter of time. For GM, Q2 saw sales of over 21,000 EVs. Definitely impressive, but down 19% year over year due to the discontinued Chevy Bolt. At Lucid, Q2 saw 2,394 deliveries. At Rivian, Q2 saw the delivery of 13,790 vehicles, and they remain on track for annual production of 57,000 vehicles. Very exciting stuff, but again, when comparing to Tesla's numbers, it really pales in comparison. The real reason this matters and why Tesla has been able to grow, though? Cost. We can look at charts like this one, which is labeled, Tesla's profit per vehicle dwindles on price cuts. It's a true statement. Tesla's profits have taken a big plunge lately due to price cuts in order to drive demand. They are down from a high in Q1 of 2022, where they made about $18,000 in profit per vehicle sold. However, for Q2 of 2024, they still earned about $8,265.84 per vehicle sold. How does that compare to the competition? Over at Ford, it was reported in May of this year that they were losing about $100,000 per EV sold. Again, they are not only not profitable, but they are fully taking a $100,000 loss for every EV that they pass off to a customer. Essentially, when looking at it this way, Tesla is making $108,265.84 more per EV sold than Ford is. Back in November of 2023, Lucid reported that their losses translated to about $227,000 per vehicle sold. This actually increased all the way to $328,000 lost per vehicle delivered in Q2 of 2024. This is coming at the same time that Peter Rawlinson, Lucid's CEO, is repeating how much better their tech is than Tesla's. Maybe he's right, but ultimately, at losses this large, how much does it really matter? Well, we'll get there. At GM, they aren't as open about their specific EV sales, but they have been clear that they are still not profitable on electric cars. In fact, most recently, they said that margins on EVs are substantially negative. They expect to be profitable in 2025. At Rivian, they reported a loss of $32,705 per vehicle sold in Q2. They have been clear that they have a path to profitability by the end of the year, or into 2025, but still, that puts Tesla making around $40,000 more per EV sold. As a whole, including all companies, a recent report found that, quote, automakers lose an average of $6,000 on every EV they sell for $50,000 after tax credits. That seems low in some cases, but essentially we're looking at a pretty clear story, especially with EVs sold in the United States. Tesla actually makes money on every car that they sell, while everybody else is struggling. If we take that $6,000 figure, then Tesla makes $14,265 more per EV sold than other companies right now. But they make up to $336,000 more per EV sold than someone like Lucid. One thing that somewhat separates these companies is the difference between an EV startup and a legacy automaker diving into EVs. For companies like Lucid and Rivian, their future depends on making electric vehicles. They have to put everything into that technology because their entire company depends on making those specific products profitable. For legacy automakers like Ford and GM, these bad numbers have an impact, but they can kind of push through to a degree, keep numbers relatively low to minimize EV losses, and rely on gasoline vehicle sales to fund this part of their business. At least they can do that for now. Either way, it's a huge disparity, and it's the one thing that often doesn't seem to be understood in this industry. A lot of people compare, say, a Tesla Model Y to a Cadillac Lyriq and say, well, the Cadillac is obviously a better car. The Model Y is a budget car that is overpriced compared to the Lyriq. Maybe that could be argued, but at the end of the day, if GM has no road to making money on the Lyriq, it doesn't matter. It won't be around in the future. Sure, the Model Y's interior is simple compared to many of its latest competitors, and I do think it needs an upgrade, which it should be getting in 2025. But when Tesla gives it to a customer, they make money. That cannot be said for a single other car competing with the Model Y, especially in the US. In fact, many automakers are backing off on their production. In part, this comes because demand for the offerings from these companies is not growing. But when you think about it as well, if a company is not looking at explosive sales, and they are already losing anywhere from thousands to hundreds of thousands of dollars per vehicle sold, they have no real reason to continue growing exponentially. Recently, it was reported that Toyota had cut their 2026 global EV output plans by 1/3. They still have decent plans for 1 million vehicles made in 2026, but that is reduced from 1.5 million. Volvo had an ambitious goal to have all of their cars be fully electric by 2030. They planned to be EV only, and now they aim to have 90 to 100% of their vehicles sold by 2030 be fully electric or plug-in hybrids. That leaves a lot of leeway to keep making gasoline vehicles. Earlier this year, GM cut their production forecast by 50,000, bringing it down to 250,000 units for the whole of 2024. Last month, Ford announced that they were slowing their EV plans. Honda and GM had plans to partner on an affordable EV, but decided to cancel the collaboration. Mercedes delayed their EV goals and now aims to have 50% of their lineup be, quote, electrified vehicles by 2030. There are many factors at play here, and it's very easy for people to see this and say, see, there isn't demand for electric vehicles. But it's a bit more complicated than that. Demand is indeed slowing for expensive electric vehicles, and cheaper options need to come about to see explosive growth once again. Early adopters have in large part already bought in, and even with incentives, these cars can come at a premium. However, it would be a much different story if even a single one of the companies I just mentioned was profitable on the electric vehicles that they sold. If they were, it would be in their interest to continue scaling to drive down cost further, lower prices, and see demand increase. So why is this so difficult? Why is Tesla the only one to figure out this puzzle? Putting aside Lucid and Rivian, Tesla is the newest to the automotive business, so most would assume they would be far behind. As I mentioned earlier, the main reason that automakers have trouble making profits on EVs is because of their batteries. In order to deliver an EV range of around 250 to 300 miles, or most are aiming for, this typically requires a battery pack around 80 kilowatt hours or more. Of course, the larger the vehicle, the larger the pack, meaning the more expensive it gets. We're used to larger vehicles being more expensive, but when it comes to electric vehicles, current battery pricing is around $139 per kilowatt hour. That puts something like a Model Y battery pack around $11,398 with these numbers. That $139 number is also a recent low and an average, so some companies will be paying more and some less. However, one thing that Tesla has been very successful at is scaling. Their battery factory with Panasonic in Nevada has helped them to ensure great efficiency across their current vehicles, and they're also one of the most diversified companies when it comes to battery supply. They currently build cars with batteries from Panasonic Japan, CATL China, LG South Korea, Panasonic Nevada, BYD China, LG China, and themselves. This is one of the big areas that Tesla has a leg up on the competition. Many automakers simply try to buy battery supply and put it into their vehicles, but it takes what Tesla would call a first principles approach to scale that. Not only does their supplier have to be up to the task of scaling, but being much more involved in that process is important. Tesla does many different things to bring this fundamental cost down. First, in addition to having good relationships with their suppliers, they also have relationships with the companies providing the raw materials to those battery makers. Tesla has talked about optimizing this lithium supply, for example, that then goes to their battery partner. For the future as well, they are getting into the lithium refining business by opening their first lithium refinery in Corpus Christi, Texas. Little things like this help Tesla to stay ahead, but when it comes to the Cybertruck, Tesla is making their own batteries entirely in-house. Their 4680 battery is something they unveiled in 2020, and they have been slowly working on getting it to scale. It's definitely a difficult task for Tesla, and they have hit many roadblocks, but they say that they expect to have their own cost in line with their cheapest competitors by the end of the year. There are many advantages that come with these batteries, but the main ones have to do with manufacturing efficiency and parts reduction. From there, cost will likely continue to come down and could drop dramatically with new advancements like their dry cathode technology. Tesla recently completed their first Cybertruck prototype using 4680 battery cells made in this fashion, and said that the advantage here is, quote, cost reduction, also a much more environmentally friendly manufacturing process that will enable us to scale production much quicker. This is where Tesla is moving for the future and will likely expand for their future cars. It's essential due to how expensive battery packs are. Part of the reason Tesla has so many suppliers for batteries, though, is diversification, general supply constraints, and localization. When building a vehicle of any type, you are taking a collection of parts made in-house or by suppliers, typically shipped from many different locations around the world, and putting them all into one final assembly. When looking at the final cost of a vehicle, you have to account for manufacturing, shipping, and every single factor involved with every part of a vehicle. That's where Tesla and localization come into play. Tesla's Giga Shanghai was the second factory they built to manufacture vehicles, and over time this has become their most productive. It also has become their most cost-efficient, in large part thanks to localization. Reports earlier this year stated that for the Model 3 and Y out of Giga Shanghai, Tesla has achieved well over 90% of their parts being sourced from domestic companies. Quote, this localization strategy not only optimizes Tesla's operations, but also reduces operating costs significantly. At Tesla's US factories, they have a very similar approach, and it can be seen pretty clearly when looking at which cars in the US are the most American-made. The Model Y is the #1 most American-made car, according to Cars.com, and the Model S and X remain in the top 10. For their methodology, they say, our study ranks 100 vehicles judged through the same 5 criteria as it's been since the 2020 edition. assembly location, parts content, engine origin, transmission origin, and US manufacturing workforce. More than 400 vehicles of model year 2024 vintage were analyzed to qualify the 100 vehicles on the list. For the Cybertruck, Tesla has clearly taken a very similar approach. The Monroney sticker on the car shows that 90% of the Cybertruck's parts come from North America, with 65% from the US and Canada and 25% from Mexico. All assembly takes place in Texas as well, and as I discussed with 4680 cells, Tesla makes those in-house. They have a pilot plant for those cells in Fremont, as well as production lines in Texas. When comparing to competition, a vehicle like the F-150 Lightning only has 38% of its parts sourced from the US and Canada. This in part is likely why Tesla is on track to have the Cybertruck profitable quicker than any other automaker when it comes to EV trucks. While the Cybertruck is a wild design and came after a few other compelling electric trucks like the F-150 Lightning and Rivian R1T, we're seeing the same profitability story here. Ford and Rivian still lose money on their electric trucks that have been on the market for a couple years. While it was only introduced at the end of 2023, Tesla has said they will be profitable on the Cybertruck by 2025. Localization is a huge factor here, but so is vertical integration. Tesla is one of the most vertically integrated automotive companies out there, and we can see this clearly in a number of ways. Every chance Tesla gets, they do the R&D in order to bring every piece of their vehicles in-house. The biggest piece there is software. Modern electric vehicles are extremely driven by and reliant on great software. First, a car being designed around a screen and software controls helps someone like Tesla bring down cost, simplify manufacturing, and then improve their cars for customers throughout ownership with over-the-air software updates. It's great for Tesla, but for most automakers, software has traditionally been something that they outsource. In the past, this wasn't too much of an issue, and even today we see many companies ship cars with fairly old-feeling software, since most users will opt to use Apple CarPlay or Android Auto anyway. However, software extends far beyond that which users engage with. This was illustrated incredibly clearly during the chip shortage a few years back. Companies saw huge losses during the chip shortage, since they simply could not ship cars without the chips that they needed. However, while most companies struggled throughout this period, Tesla's production and deliveries only grew. Not only had parts simplification allowed Tesla to require fewer chips in production, but thanks to vertical integration, Tesla was able to pivot instantly. Quote, "We were able to substitute alternative chips and then write the firmware in a matter of weeks. It's not just a matter of swapping out a chip, you also have to rewrite the software." Tesla writes their own firmware and software, so they were able to get chips wherever they could and make them work in order to keep vehicle production flowing and growing. On the other side of things, Ford's CEO Jim Farley clearly illustrated what it looks like on their side. Jim Farley has been fairly open about the ways Tesla is revolutionizing the industry, and he said that at Ford, quote, "We farmed out all the modules that control the vehicle to our suppliers because we can bid them against each other for price. So Bosch should do the body control module, someone else to do the seat control module, someone else to do the engine control module. We have about 150 of these modules with semiconductors all through the car. This not only causes delays when something needs to change in production, but can cause legal issues. So even though it says Ford on the front, I actually have to go to Bosch to get permission to change their seat control software. Even if I had a high-speed modem in the vehicle and I had the ability to write their software, it's actually their IP. We call it the loose confederacy of software providers. 150 completely different software programming languages. All the structure of the software is different. It's millions of lines of code. Ford is having to take a page out of Tesla's book for their upcoming cars. And Jim Farley further said, "What we've learned about electrification is it's actually not about propulsion systems. It's really about what you can do outside of the propulsion system and also the software. That's why at Ford we've decided in the second generation EV product to completely insource electric architecture. To do that, you need to write all the software yourself, but just remember, car companies haven't written software like this, ever. They've never written software. So we're literally writing the software to operate the vehicle for the first time ever." The software side of things cannot be overstated, and we see it across multiple industries. Modern products equally rely on great hardware and software, but bad software can entirely ruin great hardware. Over at VW, CEO Herbert Diess lost his job after severe software development delays pushed back the launch of new Porsches, Audis, and Bentleys. In fact, this is a large reason why VW and Rivian are now partnering. Quote, "Rivian will share its expertise on building software and electrical architectures." Outside of the automotive world, Sonos recently slowed the rollout of a few major products. Not only have they scaled back production of their brand new headphones, but they have delayed the launch of a TV set-top box, all because of software issues that have affected their mobile app. Outside of software, though, Tesla controls so much of what they do. 2 years ago, they detailed their Tesla Glass department. They specifically custom design their glass and their roof tints, and design it in partnership with the safety teams. When it comes to vehicle sound systems, you may think that you always want a brand name. Bowers & Wilkins, Bose, Meridian, these are all companies that make great automotive sound systems, so Tesla designing it themselves may not excite you much. However, Tesla bringing audio engineering in-house has led to some of the best sound systems on the market. They have much more ability to custom design the system for the car, and especially in their latest vehicles, it's noticeable. Tesla sound systems are fantastic, and the benefits to their own system extend to cost. They are not paying a third party for development or paying royalties. They engineer it for their car, they can pivot or change things whenever necessary, and their cost on the final product is lower as a result. For motors, Tesla does the same thing, designing and producing motors entirely in-house. Here's the latest new motor they are shipping on the Performance Model 3, and Tesla produces these motors at their own factories for their own cars. This vertical integration means that after R&D, their only cost is production. They can constantly iterate to bring down cost, and shipping is optimized for each production line instead of traveling far. When it comes to cost, Tesla is always focused on ways to bring it down. In every department, a cost reduction as little as 1 cent is sought out, since those things compound and add up over time. Every time they can delete an unnecessary part, they do so, and this is part of why their cost of goods sold consistently has decreased over the years. Quote, cost of goods sold, which is also referred to as COGS, refers to the direct costs of producing the goods sold by a company, including the cost of materials and labor to create the product. This chart shows clearly how well Tesla has done in cost reduction on their vehicles over the last couple of years. This meticulous focus allows them to stay ahead of the competition when it comes to profitability, and their vertical integration ensures that they are never standing still. After this report, they said, our team remains focused on growing our output, investing in our future growth, and finding additional cost efficiencies in 2024. This can be seen in all of the small details that we're talking about here, but especially at a large scale with things like their Gigapress. The idea for the Gigapress originated from the way toy cars and their underbodies are cast, and ultimately led to Tesla taking the rear underbody of the Model 3, which was 70 pieces, and making it 2 for the Model Y. The entire underbody of the Model Y was simplified to 3 pieces: the front casting, rear casting, and battery pack. That may not sound like a lot, but in the process, quote, Tesla was able to remove 600 robots from assembly. That is a huge savings to the production line. After the R&D Tesla funded for these massive casting machines, they now can realize the benefits of fewer parts, faster production, lower material cost, improved efficiency, and improved structural integrity. They have done the same with the Cybertruck as well, which utilizes the largest casting machines ever made. Then, for future platforms, Tesla has many different plans to help reduce cost. They want to get to a future of a single underbody casting and an entirely different unboxed assembly process. Many in the industry say that this will be revolutionary once Tesla is able to put it into place. It allows for more work to be done at once on a vehicle. Tesla actually just filed patents for this process, and they plan to utilize it for their upcoming robotaxi in particular. In the application, they shared a number of photos and say, quote, a modular vehicle architecture for efficiently assembling vehicles. The modular vehicle architecture includes preparing a plurality of individual sections of a vehicle in a plurality of subassembly lines prior to forming a full body frame of the vehicle. The vehicle architecture further includes joining the plurality of individual sections of the vehicle in a main line. The full body frame of the vehicle can include a front side, a rear side, a top side, a bottom side, a left side, and a right side. It will likely be a few years before we see Tesla fully implement this process, but seeing their patents shows that this is much more than a lofty goal. I detailed this a lot more in depth in my video about Tesla's production speed, which is linked below, but all of this clearly demonstrates why Tesla is ahead. They never stand still. While on the outside their cars look the same for many years, on the inside, things are constantly being improved and optimized. Vertical integration is a big reason why we see Tesla's main competition actually coming out of China. When speaking about these companies, Elon Musk said, if there are no trade barriers established, they will pretty much demolish most other car companies in the world. They're extremely good. Ford's CEO Jim Farley spoke about BYD in particular, saying, we've never seen a competitor like this before. BYD is totally vertically integrated. Their scale is something we've never seen. All of these things used to be helpful, but are now essential in order to make viable electric vehicles. One last piece of Tesla's vertical integration expands to their delivery system. Instead of utilizing dealers, which can add cost and mark up prices for customers, they sell directly to consumers. Further cost reduction. Now, one very common rebuttal people throw out regarding Tesla's profitability is something along the lines of, they just receive government subsidies. Well, let's look into that real quick. Tesla did receive a $465 million ATVM loan to develop zero-emissions vehicles. They paid this loan back in 2013, however, 9 years early. Other companies who also received these loans paid them later, defaulted, or haven't paid them, including Ford, who received a whopping $5.9 billion. Regarding regulatory credits, these are something Tesla has made money with over the years. Automakers who can't sell enough zero-emissions EVs can pay other automakers for credits to ensure they qualify for government requirements. Tesla, of course, sells way more EVs than they are required to, so they can make extra money this way, and they do. For example, Stellantis bought about $2.43 billion of green credits from Tesla between 2019 and 2021. In 2023, Tesla made $1.79 billion from these. That's a chunk of money for sure, but considering they had an $8.9 billion GAAP operating income in 2023, it's clear that they profit plenty without these credits. So Tesla's optimization really is what makes the difference here, and the last one is a big one, self-driving technology. Today, Tesla ships every car they make, technically with the exception of the Cybertruck yet, with basic autopilot. This system does adaptive cruise control and auto steering to keep you centered in your lane for long stretches of clearly marked roads. For the average customer, this means that they have compelling self-driving available right out of the gate. However, beyond that, Tesla sells their full self-driving supervised system. Today, they say that, quote, your car will be able to drive itself almost anywhere with minimal driver intervention. The development of this system, and the claims from Tesla and Elon Musk as to what it will be able to do, have very much muddied its perception. But one thing people don't fully realize is how far Tesla is ahead in this space. Especially when compared to other automakers, nobody is really close. Tesla's full self-driving technology is built on a learning neural network that collects data in order to improve the system every time a user takes over. As of April, Tesla shared a chart that they had collected over 1.3 billion miles of data with FSD doing the driving. Since then, they have also said they've exceeded 1.6 billion miles driven, and the latest data in that red zone is their latest version 12. This was a big step forward in the system, and more users are finding that it's very impressive. It's pretty clear that in regards to safety and general technological advances, self-driving cars are the future, but it's really just a question of when. To deliver self-driving, Tesla utilizes cameras around the car and their internally designed FSD computer. This once again is deep vertical integration. They have also been shipping this hardware on their cars for years, meaning that millions of customers are already collecting billions of miles of data for Tesla. It's something that almost feels impossible for others to catch up to. Then on the training side, in addition to utilizing NVIDIA technology, they are building their own Dojo supercomputers optimized for AI. For other companies introducing more advanced self-driving technology in their cars, we are seeing them once again needing partners. That's because delivering a system like this takes years of development, and in particular, software development. For instance, in March of this year, VW announced further partnerships with Mobileye for their supervision and chauffeur platforms. Over at NVIDIA, they are often at the forefront of AI technology, and their Drive platform has a huge list of partners, including Mercedes, Volvo, BYD, Hyundai, Polestar, and NIO. That's not inherently a bad thing by any means, but it means added cost anytime these companies want to deliver these features on vehicles. On Tesla's side, they do have to spend billions of dollars developing these systems, and will continue to do so, but long-term that investment could pay off as a major cash cow for FSD purchases. Then if they can deliver on their robotaxi, that's a whole different subject, and a whole other business that Tesla will exclusively own. Essentially, they could become the company licensing this tech to others, and that's something they have even discussed in the past. Tesla's approach has been specifically AI training based, with cameras being the only sensors used, whereas other companies in the robotaxi space use complex LiDAR sensors. Years ago, Elon Musk called LiDAR a fool's errand, and now it seems that companies like Mobileye are proving him right. They are discontinuing their LiDAR R&D division by the end of the year and laying off around 100 employees. That's after spending lots of time and resources developing this specific technology. With that and many other things, Tesla's ability to make more than anyone else comes down to a head start. Tesla wasn't always profitable. Like most startups, it took them years to realize their first profit. At this point, we're used to them making money each quarter, but Q1 of 2013 was their first profitable quarter, thanks to the introduction of the Model S. Not until 2020, however, did Tesla post a full calendar year of profitability. That means that it took them a full 17 years from their founding in 2003 to be consistently profitable. From the introduction of their first car, the original Roadster, it took them 12 years. And from the introduction of their first true mass market vehicle, the Model S, it took them 8 years. So when we compare to many competing brands, they are just starting to introduce and scale their first true all-electric vehicles. The main difference is Tesla did that 12 to 16 years ago. Even if you only consider the Model 3 to be their first mass market vehicle, that's a 7-year lead ahead of competing vehicles. So it's easy to look at Rivian and say, how come they can't make any money yet? But really, Rivian is in a similar spot to where Tesla was around 2016 or so. They're just entering a market with much more interest in EVs and much more availability of batteries and such. So they should be able to get profitable faster than Tesla did. That's the hope at least. Those numbers we talked about at the beginning of this video may seem like hyperbole, but they are based on the actual numbers occurring in the US EV market today. As we move through the next few years, it will be very interesting to see how things change, and the hope is that all these companies truly figure out how to make profitable, affordable EVs. For now though, Tesla makes more than anybody else on their cars, and it seems they may keep that advantage for some time going forward, especially if they can introduce cheaper vehicles in 2025, as is the plan. I hope this video was helpful in understanding the EV market, and in the meantime, if you want to see how Tesla makes a new car every 13 seconds, you can check out that video linked up here or in the description below. Thanks so much for watching, and I'll see you on the next one.